Alright, hey guys, wanted to make a quick video here. I'll try to keep it as short as possible, but it could take a couple minutes. At the end of the day today, we learned something that's really too confusing to just put on paper, or at least for me it is. It was a problem very much like this one. They're a bit different. Car 1, a dot diagram with two objects in it. The top line of dots is car 1, this line, right here, kind of just, and the bottom line right here is car 2. And let's take a quick note here of which car is, what pace is the car moving at. Now, they both appear to be moving at a steady pace. Let's just pretend in some sick, twisted world that these dots are the same distance from each other, because that was what the problem was. So, let's pretend that these are all the same distance apart, and we'll need a steady pace. So, Mr. Finley said to us, okay, so for every two dots are the same, circle them both. So, like, let's say two dots were like this. Say you saw two dots. Oh, hold on. Like here, you'd say, oh, look, these are in the same place, so I will circle them. So, basically like that. And almost everyone in the class, I think Mr. Finley said 92% of us, answered it a little something like this. Like that. So, he checked our answers and said almost everyone got it wrong. And we didn't know why. It turns out that the only two dots that were in the same place were... I'm sorry, it takes me a while to erase this. I'll just keep talking. Were the first two dots. So, it should have looked like this. And I think he said only 8% of the class got it. I didn't get it right. So why is it like this? It is like this because none of the dots over here past this line, none of them are in the same place. They both start at the same place, but after that they're going at totally different speeds. So they're in totally different places. Now, I mean, of course, the two objects are at different speeds, and doesn't necessarily mean they'll be in different places, but they're both moving at steady paces, and car 1 is moving faster than car 2. How do we know this? Well, because each dot represents a second, where an object was in that particular second. And so the first dot after dot 0 should be second 1. So this dot is second 1. Right? And for car 1, this dot is second 1. Do not label it like this ever. You're not supposed to do this. I'm just doing this for the sake of learning. And since this is the second dot away from dot 0, this is second 2. And these can't be together because this is second 1 and this is second 2. They're different positions. So, car 1 is moving faster than car 2 because the dots are farther away than car 2's dots, to be juvenile. And so, how do we label which dots are the same? You know, which dots represent the same second? So what we do to label that is what we learned in class, is that we go like this. So here's dot number 0 for each, put a line in between them. Go to dot number 1 for car 1, put a line from that to dot number 1 for car 2. Dot number 2 for car 1, put it up with dot number 2 for car 2. They're not supposed to be curved, they're supposed to be straight, but I don't have a ruler. Dot number 3 to dot number 3. And so on. These are off the papers. You'd go on and on and on. So that's kind of what we did in class. That was a really brief explanation, probably pretty bad. But really all you need to know is that in a situation like this, these two dots right here are not in the same place. These two dots are. I'm sorry, not in the same place. These two dots are not in the same place. None of these dots are in the same place except for the first two. Because these dots are not in the same place because these both represent number 1. This represents number 2. So, yeah, you get the idea. To be in the same place, 1 has to be directly above 1, which in this case it's not. So I hope you enjoyed this video, and alright. Hope it helped.